Yeah, okay, so I'll be talking about our gastro data board, which is built on our gastro data. Then I'll give a brief introduction about the gastro study first. So for our gastro study, we collaborate with hospitals and research institutes to do this study. And this study, at first we recruit them when the moms are about 7 to 11 weeks pregnant. Then we recruited about 1,450 women. And during the delivery, there are about 1,209 deliveries. Then currently the kids are about 13 years old, and we have about 800 plus participants who are still active. Yeah. Then we use this gastro data and created a gastro data board, which allows the researchers to go to this website and look for the variables that they want, and they can request the data that they want to use for their research from us. And they can also look at the past publications that people have been doing on the gastro data. Then we currently started on doing the gastro data to conversion to the OMOP data format. Then we are using the CDM version 5.4, and because of the limitations of the gastro data, because we only have demographics, metabolics, women's health, children's health, mental health, and imaging and omics data. So the OMOP tables that we have are quite limited, it's the person table and mainly the observation and measurements table. Yeah. So currently when we do the mapping, we are using Athena and customized R scripts. Then so now we created it's in progress. So I will be showing some prototypes for the OMOP data catalog that we should be introducing out soon. Yeah. So we use the FAIR guiding principles, and the data profiling of the OMOP concept IDs allows our gastro data to be identified, described, discovered, and reused by the researchers. So yeah, this is a sample of the OMOP data catalog that we will be introducing soon. Then you can see that there's this search button, so researchers can perform a search on the variables that they want. And there are some attributes that they will be in this data catalog. So it's like the concept ID and the synonyms for the OMOP data, and also some basic description and where the data is from, whether it's from the mother, father, or the child. Then for some variables which have categories, the researchers will be able to expand it and see the different categories in the data. Yeah. So our conclusion is that the data schemas can vary for population health studies. So the OMOP data catalog we developed is for the Singapore cohort study. So other countries might be a bit different. And we hope that we can develop cross-study OMOP data catalogs across the APAC and Global ODC committee. Yeah, that's all. Okay, thank you.
Thank you, Cindy. Okay. So speaker number 2 from China, we have Lei Liu, and the title is Establishment of Evidence Sharing Network through the Common Data Model for Chinese Clinical Research and Overview. Thank you.
Thank you for the introduction. So it's okay. I have to, make a explanation just because this is not really my study, So I'm just the authors cannot come. So then they give me the slides and ask me to present for them. So I will try my best, okay? And also because actually when I look at the slides, it's about the Chinese clinical research using OMOP model. So besides their studies, I actually I know a little bit more about the situation in China. Okay, so the study is really about kind of a survey to see how many hospitals or how many institutions is using OMAP, right? So they did some literature search and also some survey to see how, the purpose is try to summarize the prior work, related to Chinese agency using OMAP. So that's what it is. And how they do it? So they check the literature and also they look at the studies published, and then they see there's about 12 hospitals and or institutions using OMAP, and some of them have like an international. Some of studies have international multi centers. There's 4 of them, and then 3 of them is a domestic multi-center, and then the 7 of them is just a single hospital. Okay, and they look at the how many the patients involved, how many records involved. Actually, it's not that many, right? So, but they give us 3 examples. The first one is one hospital affiliated with Nanjing Medical University, and this one actually convert pretty big, records. There's more than 6 million records being converted into an OMAP model, and actually I happen to know this work because I know the president of this hospital and how they did it, and the second one is from in one of the hospital in Beijing, and they actually did like a cross region study, and they study. I think they're on the psychiatric studies, the patients. So, and the last one is a regional. It's actually it's not only one hospital. It's within a small region. This region is in Ningbo, a city in close to Shanghai actually, and in one of their district, and they convert about 300. They have about 300, more than 300,000 patients with diabetes, and more than 900,000 with hypertension, and the overall is more than 100 million records. So it's pretty big database as well. So all these 3, just the example to they're using OMAP models, but comparing the whole country, I mean, this 3 is actually just a small portion. So and in reality, I think that the OMAP model OHDSI is still not very common in China yet. But we have a OHDSI China chapter, so we try to promote more and then try to move forward and to allow more hospitals and more institutions be able to adopt OHDSI OMAP model. So future directions, and there was some, why it's not. They're asking why this OMAP model is not being adopted widely. And one thing is, if you think about China, actually is a large country, and then the hospital, their HIS systems, their EHRs are really different vendors. This situation is pretty bad because there is not like I think US probably is only 2 dominant vendors, but in China there's maybe hundreds of vendors out there. So it's hard to really for the hospitals or for the institutions actually to collecting data and then convert that into an OMAP model. That is something we have to make a lot of effort to try to have all this more than hundreds, maybe thousands of vendors, their systems converted to an OMAP model. And actually, we have a poster from my institution, the Fudan University. We try to do it. We try to have our affiliate hospitals to convert that into OMAP model. That is underway, so we haven't finished yet. So hopefully maybe next year we can have something presented, which Fudan University's OMOP model. Another thing is because we have a lack of experience, insufficient training. So for that part, I also like to, for OHDSI China, we try to make more training programs and make more kind of workshops to teach more people to be able to run this OHDSI OMOP model. And for that, I also really need help from all the communities. And I think Wui and Patrick has been helping us quite a lot, and then give a talks in China a couple of times. Because of pandemic, we haven't done that for several years. But hopefully, in the next few years, we can keep up. Okay, so thank you. Okay.
Okay, next up, we have Yoshihiro Aoyagi from Japan with the internationalization efforts for real-world evidence creation at core hospitals for clinical research in Japan.
Okay, hello everyone. My name is Yoshihiro Aoyagi. And I would like to express my appreciation for this great opportunity today. I'm a manager of the Medical Information Department at the National Cancer Center Hospital East. And I'm very pleased to be involved in the Japan Real-World Data Project named LinkedIn and its global initiatives. Today, I will briefly discuss this Japan project and its significance in globalization in this session. Oh, this is title. So currently, LinkedIn is focusing on developing a framework that allows us to extract good clinical data from core clinical research hospitals and to ensure the accuracy and reliability of the data. They have implemented quality control methods. The final goal is to establish a comprehensive framework to integrate and analyze this data. To achieve this goal, we have 6 groups. Through collaborative group activities, we are developing a framework including vocabulary management, data integration, and quality control. These 3 aspects are important for ensuring accurate and meaningful analysis of the extracted data. Additionally, we understand the importance of training skilled human resources. So therefore, we are training them with the necessary expertise to handle this difficult project. There is one point to be mentioned regarding the activities of the LinkedIn. It is that the scope of these activities was originally domestic Japanese research. We felt that only domestic research was not enough, and we are looking for a scope toward international research. As a result, LinkedIn is now looking to target OHDSI and OMOP to produce data that will contribute to international research. The globalization team was started at the end of 2021, and throughout 2022, significant progress has been made with the introduction of several tools and test data. And looking ahead to 2023, our focus will be on terminology conversion and transforming medical data from EMR into the OMOP format. As you know, the terms commonly used in the OHDSI are not widely utilized in Japan. So handling this challenge is very difficult but we are committed to developing these systems. Our plan involved a gradual conversion of our data into the OMOP format beginning after 2024. By advancing these efforts, we maybe bridge the gap between Japanese medical terminology and the OHDSI standard, and ensuring compatibility and facilitating seamless collaboration with the global research community. Finally, we would like to share a summary of our very small achievement last year. For understanding OHDSI, we have prepared in instruction manual and functional descriptions for the OHDSI tools in Japanese, which can access on website. But regrettably, due to time limitations, we are unable to focus on accuracy and data quality dashboard this year. However, it is expected that some progress will be made in these areas later. Furthermore, we have created a document that explains the overview of OHDSI for the Japan team. And I would like to introduce my colleague who has been working on this project. Their effort was very important, and I will also like to express our deep appreciation for the support from AMED. I will close my presentation. Thank you for your kind attention.
Okay, speaker number 4, we have Roger Ward from Australia with successes and challenges of a multi-state electronic medical record to OMOP conversion project.
Thank you. Hi, everybody. I thought I'd use a roving mic because I sort of wander around the lectern and I notice people fading in and out. So, welcome to Australia. I want to talk to you about successes and challenges of our electronic medical records conversion project in Australia. We've been going for 2 years so far. So why did we do this? Well, I'm from the Department of General Practice at Melbourne University, and we converted our primary care data set to the OMOP Common Data Model back in 2020, 2021. And at the time, I was talking to my boss, who's here in the audience, Professor Dougie Boyle, and we said, wouldn't it be great if we could work with the hospitals and do the same thing in the hospitals and promote this? So Dougie, has a lot of contacts in the hospitals. So we put together a grant application with 12 different collaborators, including Angus Ritchie, who's in the audience, and Graham Hart, who's in the audience at the back there. And we got some funding from the ARDC, which is the Australian Research Data Commons, to do the work. And this enabled us to form a partnership across Australia to do the conversions. And the overarching aim of this was to share intellectual property, to share ETL, to share governance procedures, to share mappings. So rather than reinventing the wheel each time in each hospital, we'd share the resources. So how did we do this? We partnered with OHDSI Australia. Nicole is the president of OHDSI Australia. We did some webinars. We introduced people to the OMOP Common Data Model. We encouraged people to do the Asia Pacific ETL workshops that MUI kindly organised. So we encouraged our people to do that. We promoted the Eden Academy. We told people about the Eden Academy and how they could learn about the OMOP Common Data Model from the Eden Academy. And importantly, we shared resources and ETL scripts across organisational boundaries. So the idea was we were to combine resources to make it more efficient. So let's look at some where we are now. In 2022, we had 1.2 million patients converted, and that's the data set that's in University of New South Wales. So Blanca's team at University of New South Wales converted that data set. And currently, we're working on the Austin data set, which is Austin Health in Victoria, and we've converted another 1.2 million patients to the OMOP Common Data Model. But interestingly, the team at University of New South Wales are doing that work. So it's an example of collaboration working across state borders. The next cab off the rank is Western Health in November 2023. And again, University of Queensland are going to do that work at Western Health. So we've got a very talented Cerner analyst at University of Queensland who's going to help Western Health with that work. Queensland Health, this is the panacea. We really want to do Queensland Health. It's a very large data set. They've got a shared Cerner EMR in Queensland with around 4 to 5 million patients in it. So we really want to do that data set. They've converted their test data set, but they've not done the clinical data yet. So we're hoping to get Queensland Health next year or towards the end of this year. And that'll take us up to potentially 6 million patients converted. Okay, the title of the talk was Successes and Challenges. The key success, as I see it, and I'm very proud of, is the community of practice that we've built across Australia. And it's across all levels. It's technical staff, it's hospital, it's senior hospital executives, it's clinicians. So it's really satisfying to see that. The challenges we've faced, finding skilled staff to do the work. There's a shortage of people with these skills. So what we've done is seconded operational people into research roles. And that's worked really well because they bring all their operational knowledge to the research domain, but they've got protected time to enable the research. So I'd just like to give some acknowledgements to the ARDC who kindly funded this project and the Australian Health Research Alliance who I work for. Okay, thank you everybody.
Okay, speaker number 5, we have Ivan Lam from Hong Kong with the Association of Short, Medium and Long-Term Cardiovascular Sequelae with COVID-19 Infection, a multinational pilot study. Thank you.
Right. Thank you, Sarah, for the introduction. So my name is Ivan. I'm from the Department of Pharmacology and Pharmacy at the University of Hong Kong. And today I would like to speak to you about this project that our team has conducted, which is on the Association of Short, Medium and Long-Term Cardiovascular Sequelae with COVID-19. And this is a pilot study that we have conducted. First of all, some background. So from existing studies, we know that COVID-19 infection is associated with a range of cardiovascular sequelae and can result in associated mortality. However, the risks of cardiovascular sequelae remain unclear owing to the large variability in terms of the risk estimate from these existing studies, which differs in terms of their study designs, population, and how they select and define controls. So the aim of this study is to evaluate the risk of these cardiovascular sequelae in short, medium, and long term using multinational healthcare databases. The reason why OHDSI provided a great platform is because the existing tools and packages available within the OHDSI network allowed us to build a standardized package which allowed us to systematically apply the same method across multiple databases mapped to the OMOP Common Data Model to generate some coherent findings. So in terms of the study design of this study, is actually fairly simple. This is a retrospective cohort study. We aim to match the two study cohorts, which comprises of individuals with and without COVID-19 between the 1st of December 2019 to 2020. We aim to match them by propensity score conditioned to the chances of getting COVID-19 infection. The study outcomes included 9 of the cardiovascular sequelae, and the short, medium, and long-term risk windows are defined as up to 6 months, from 6 months to 1 year, and 1 to 3 years after their initial COVID infection. And as I mentioned before, this is a multinational healthcare database study, and we are still open to anyone who wants to join us. So please do get in touch if you are interested. So here are some of the preliminary findings that we have obtained so far. So on the flowchart on the right, you can see how we selected the study population for each of the study outcomes. So after we identified patients from the target and comparator cohort, we excluded those who have a history of the particular outcome of interest, and those with less than 1 day at risk, before we conducted the propensity score matchings between the two cohorts in a ratio of 1 target to up to 10 comparator. We excluded those who cannot be matched to a target and a comparator during the matching before we arrive at the final study population for each of the study outcome analysis. So we can see from our preliminary findings conducted using the Italy LPD database, there is an increased risk of several cardiovascular sequelae, including arrhythmia, myocardial infarction, heart failure, hypertension, myocarditis, and pericarditis, which may persist for up to 3 years after their initial COVID-19 infection. So moving on, based on our existing findings, our next step will be to evaluate the risk of these clinical sequelae in the short, medium, and long-term risk window. We are currently adapting the package with the help from IQVIA, so just want to acknowledge their help and support on this study. And once we've completed modifying our current study package, we will begin our data analysis process in these databases from IQVIA and also our collaborators from Korea. So thank you for their support. And this is all from me. Thank you very much for listening.
Okay, penultimate speaker. So from Korea, we have Subin Kim, slightly longer title. We have, with the title of Comparative Risk for Neuropsychiatric Events in Leukotriene Receptor Antagonist versus Inhaled Corticosteroids in Children with Asthma.
Thank you for your introduction. Yep. Hi everyone, I'm Subin Kim from Yonsei University in College of Medicine. I'm currently working as a student in Professor Chan's laboratory, and today I'll talk about comparative risk for neuropsychiatric events in leukotriene receptor antagonists versus inhaled corticosteroids in children with asthma. Current guidelines recommend ICS as the preferred control medication and LTRA as alternative in children with asthma. However, LTRA are sometimes more favored over ICS due to the low adherence and potential side effects of ICS. In 2020, the FDA issued a black box warning to alert the increased risk of neuropsychiatric events in LTRA. However, evidence from multiple observational studies is still inconclusive. In previous studies, neuropsychiatric events are generally determined using diagnostic codes like ICD-10. However, neuropsychiatric events are often undercoded in structural EMR fields. One study found that the sensitivity of diagnostic codes of depression is lower than 80% compared with medical chart data. And this study shows the possibility of undercoding of mental disease in structured EMR fields. To mitigate these limitations, manual chart review remains the golden standard, but it is very labor-intensive and time-consuming. So recently, natural language processing has emerged as an alternative to structured EMR and manual chart review in medical research. So using NLP, we can efficiently extract the information documented in unstructured clinical notes. In this study, we assessed the risk of neuropsychiatric events in LTRA compared to ICS among child asthma by leveraging structured EMR as well as unstructured clinical notes. We used a database from Severance Hospital converted to OMOP CDM. Severance Hospital is a hospital which contains information about more than 7 million patients in South Korea. We identify patients aged between 5 and 18 years who prescribe LTRA or ICS, and patients with at least one asthma diagnosis in outpatient clinics were included in this study. And we excluded patients who had a prior history of neuropsychiatric events or use of opposing study drug before the index date. The outcome was newly developed neuropsychiatric events. In structured EMR, we identified the outcome using diagnostic codes and in narrative clinical notes. We first developed deep learning models to detect the occurrence of the outcome, and next, using deep learning models, we automatically review the clinical notes of study population and identify the incidence of neuropsychiatric events in study population. And this is the result of our primary analysis. As a primary analysis, we compared the one-year risk of neuropsychiatric events using conditional cost regression after propensity score stratification. And for sensitivity analysis, we set 4 different time and risk windows and 1 more statistical analysis. And this is a result of our primary analysis using both diagnostic codes and clinical notes. The one-year risk of neuropsychiatric events in LTRA was not higher than ICS in children with asthma. And in the below left side, you can see the preference score distribution. And this plot shows that these two groups were comparable. And the right one, the covariate balance plot, shows that baseline covariates were well balanced after propensity score stratification. And this figure shows the result of sensitivity analysis. You can see that the results were consistent across various time and risk windows, outcome definitions, and statistical approaches. And in conclusion, in this study, we identified the neuropsychiatric events in unstructured EMR using deep learning models and as well as structured EMR. And as a result, the risk of neuropsychiatric events among child asthma was not higher in LTRA compared with ICS. And this finding was consistent across sensitivity analysis. Thank you for your attention. And if you have any questions, feel free to contact us by email.
Okay, and lastly, but by no means least, from Taiwan, we have Thanh-Phuc Phan, and the title is Prediction of Dementia Incidence Among Patients with Type 2 Diabetes.
Thank you, Sarah, for your introduction. So I am Thanh-Phuc Phan. I'm Vietnamese from the West, the home country of Mui. But I'm taking the PhD in Taipei Medical University. So this is one of our preliminary research. So I simply want to present to you all sorry. So as we know, like the diabetes, they can lead to long-term complication and several types of the complication, including the cardiovascular disease, renal function disease, and also like it also take effect on the cognitive function, and it can cause like higher risk of all causes of the dementia. So we aim to establish a patient-level prediction model for the incidence of the dementia among the patient with type 2 diabetes. And we using our rework database from team Taiwan Medical University, and also apply the patient-level prediction packages from OHDSI. For our methods, like the data source is we are using the Taipei Medical University Clinical Research database, so-called Team UCRD. So the Team UCRD is pulling the electronic health record information from 3 affiliated hospitals, like under the umbrella of the Team U, and we map to the OMOP CDM. And for our population, we will focus on our T2DM patients as our cohort study. And the period of our population is from 2009 to 2019. To confirm for the type diabetes patient, we using both like diagnostic codes and the anti-diabetes medication for our population. And for outcome, For the outcome, we define the dementia patient who underwent the treatment with the prescribed anti-dementia medication among 3 medical centers of the Taipei Medical Universities. And we define the time at risk from 1 to 5 years. From 1 to 5 years. For models, we tried several models, but we selected the optimal model, that is a light gradient boosting machine. And this is our model performance evaluation. In here, we can create the IUC is around 0.89 for the training dataset, and for the testing dataset, the IUC is around 0.81. However, we have the calibration plot of the precision model is up to 1.2, and for the average precision is quite low. It's due to the imbalanced outcomes within the negatives and the positive class. And so far, we successfully used the OHDSI PLP algorithm to model the specific risk factor of the dementia among the T2DM population. And we thought that these kinds of the model can support the clinical diagnosis and can manage the complication of the diabetes patients so far. And the results can inform the clinician about when to assess the patient of the dementia risk and prescribe the medication for the dementia. Also within our team, we cannot execute those kind of the results. And one of our purposes is that we want to call for the collaboration with the partners from other affiliation to generate more real-world evidence from the others affiliation. So thank you.
Right. All right. All right. Okay. So now I'm the only person standing between you and your coffee break, right? So yes. So but then very good. We have 5-minute questions for all the speakers from the 19 talks. Anyone? Or if you have, please, if they have questions for previous speakers, are they allowed to ask? Can we be more open? And how about the previous my session speakers? I feel bad for them. Okay, any questions? Any questions? Yeah, Yizi, you look very eager. Sorry, she's my student, so I'm just arrowing her. Yes. Song Yizi is right there. Yes.
Thank you. I want to ask a question to Cindy about the gastro data. Because you mentioned the data is longitudinal data which has 13 years of follow-up. Can I ask like what kind of data type or content with a longitudinal feature?
So basically, over the 13 years, like what do we measure on those kids?
Yeah.
So for the moms and kids, we measure like anthropometry, and then there's blood tests also, and also some omics data and mental health data, demographics. There's a lot of different kinds of data that we test on both the mom and the kid. Then also when the kids is about 2 to 3 years old, then we also test like anthropometry and some mental health data sets on the fathers also. Yeah. So longitudinally, we do all the different tests for all these.
Yeah. Sorry to have to promote it. For OMOPs, you mentioned we measure the omics data. Exactly what do we measure? Do you remember?
For omics data, we have genotyping and have some like the what's that? Forgot.
Okay, you wanna how about?
Oh yeah, DNA methylation and also like the side chips also. Then there's also like the biochemical markers that we test. Yeah.
Okay, thank you. Next, could I have one more question? Yes.
Yeah, I have a follow-up question, but more for fire actually. Earlier on in the talk there. So I was wondering more about CDIS SDTM. I think some of us may be familiar with CDIS SDTM. And because for A-Star, we work with a lot of our partners from the pharmaceutical companies. So I was wondering, is there plans to have an interoperable model whereby I can move from OMOP to fire to CDIS SDTM interoperably from your settings?
You know, I don't actually know where CDISC are at the moment. We've talked on and off to CDISC over the years, but I haven't heard anything about CDISC for a couple of years. So I'm not sure.
Any reasons why that could be so? That, you know...
No, I don't know anything specific about CDISC, but mostly it's to do with life cycles and investment cycles and energy. And maybe they haven't got any at the moment, but that's really a guess.
Yeah, thanks. Because I think with the FDA submissions for CDISC, I think that's something that some of our partners are looking forward to. So that's why we're wondering perhaps, because we do data management end-to-end, so when it comes to data models, it could be something that we can offer them upfront, right? Whether they're looking at CDISC, OMOP, or FIRE, and then back-end, you can move one model to another when it comes to data integration. So these are some thoughts we have at Singapore. Happy to continue chatting.
But why would you go from FIRE to OMOP to CDISC? I would think it'd be from FIRE to OMOP or FIRE to CDISC, right? And then from OMOP to CDISC, because, you know, the way I look at it, and again, I'm not medical, I'm more technical, okay? So there's why I come in. You know, FIRE is more of the interoperable for a lot of EHRs to transmit a lot of your data, right? And then you got OMOP is more for the big analysis in the real world research. CDISC is more for clinical trials. And really what you want to be able to do is go from the source, which is the FIRE in the EHRs, down to the other two and make and then do the triangle between the OMOP and the CDISC, because that's sometimes where you want to go between real world data, using real world data to do, you know, phase 3, phase 4 clinical trials and being able to enrich it that way, right?
Yeah, that makes sense. And perhaps in the future, we can think how we can build packages around it to be more interoperable. Yeah, thanks. Thanks for the question.
Cool, great. Thanks for the question. I think we may have time. One last one. Anyone? Okay, now it's a signal, right? Everyone's looking for a break. Okay, thank you so much, everyone.